Okay, this is with respect to exercise 28 from Selena, grade 9 for mathematics. Exercise 28, question number 12, based on distance formula. The question says, prove that the points P 0, minus 4, Q 6, 2, R 3, 5, and S minus 3, minus 1 are the vertices of a rectangle PQRS. Okay, so first of all, let me draw my uh, draw a rough sketch. That's what is required in coordinate geometry. Okay, you draw a rough sketch, you get some clarity. Next, what do I do? I'll just name the vertices. I'll name them as A, B, C. Sorry, it's already given A, B, P, Q, R, S, so you can just erase it. I'll keep it as P, Q, R, S itself. Okay. So P, Q, R, and S. So P is 0, minus 4. Q is 6, 2. R is 3, 5. And S is minus 3, minus 1. Okay. See, there's see, when you have to show that a quadrilateral is a rectangle, firstly, you have to show that it's a parallelogram. Yes, because a rectangle is a special type of parallelogram. First of all, show that all the four sides are equal. I mean, the opposite sides are equal, because PQ should be equal to SR and PS is equal to QR. So once you're able to show that PQ is equal to SR and PS is equal to QR, you have only kind of stopped at stage 1. That is, you've shown it's a parallelogram. And when you go further and you show that PR is equal to SQ, then you can show that the diagonals are equal. Because a rectangle is basically a parallelogram in which the diagonals are equal. Opposite sides are equal and the diagonals are equal. So let me find out distance PQ. What is PQ? It will be square root of applied distance formula x2 minus x1 the whole square plus y2 minus y1 the whole square. It's left up to you. You can take P as x1 y1 and Q as x2 y2 or the other way around. So if I take P as x1 y1, Q as x2 y2, I get PQ as 6 minus 0 the whole square plus y2 minus y1, that is 2 minus of minus 4, which is plus 4 the whole square, isn't it? That would be 6 square plus 6 square. That's root of 2 into 6 square. And 6 square comes out of the radix as 6 into root 2. That's my PQ. Let me find out SR. Yes, distance formula. What is SR? Square root of, you have minus 3 minus 1 is S, R is 3, 5. So x2 minus x1 the whole square, 3 minus of minus 3, that is 3 plus 3 the whole square, plus y2 minus y1 the whole square. That would be 5 minus of minus 1, that is plus 1, 5 plus 1 the whole square. That is again 6 square plus 6 square, twice of 6 square, which is the same thing, which is 6 root 2. So we have established PQ and SR. Now moving on, let's find what is PS. Yeah, PS is square root of, again, minus 3 minus 0 the whole square plus minus 1 minus of minus 4, which is plus 4 the whole square. So what is PS? Minus 3 square is 9, isn't it? Because the negative goes away because of the even power 2. 4 minus 1 is 3. Again, 3 square is 9. Root of 9 plus 9. Root of 2 into 9. 9 comes out of the radix as 2, isn't it? So let me just go down. Now I have QR. What is QR? QR is square root of, again, the same thing, right? x2 minus x1 the whole square. So I can say 6 minus 3 the whole square plus 2 minus 5 the whole square. What do I get? 6 minus 3 is 3 square. 2 minus 5 is minus 3 square. Minus 3 square is same as plus 3 square, because squaring is an even power is 2, right? So it will be root of 9 plus 9, the same thing, which is 3 root 2. So what did I get here? From all these results, see from this first result that I can see PQ is equal to SR, isn't it? And here from these two I can say that PS is equal to QR. So till now what have I established? I was able to say that opposite sides are equal. PQ and SR are opposite sides. PS and RQR or QR are opposite sides. So it's still a parallelogram. Now, if I have to go ahead and show that it's a rectangle, I have to show that the diagonals are equal, isn't it? Now, what are my diagonals? Wait, I'll just draw that. See, these are my diagonals, isn't it? This is my diagonal, QS and PR. So I have to show that QS is equal to PR. Yeah. So let me find PR. Let me go ahead and find PR. Okay. So I'm just going to get this figure again down. Okay. So okay. So I've just put the figure down. So it's easy for me to relate to this. I can just remove this not required. Okay. So now let me find PR. What is PR? PR is applied distance formula. It will be 3 minus 0 the whole square plus 5 minus of minus 4, which is 5 plus 4 the whole square, isn't it? So what will it be? 3 square plus 9 square. Now that's different here. So I'll just 3 square is 9. 9 square is 81. 81 plus 9 is root of 90. That is root of 9 into 10. Because 9 is a perfect square, I'll express it this manner. So it's 3 root 10 units. That's my PR. What is my QS? See, what's QS? Just check what's QS. QS is equal to square root of applied distance formula 6 minus of minus 3, which is 6 plus 3 the whole square, and 2 minus of minus 1, which is 2 plus 1 the whole square. That would be 6 plus 3 is 9 square plus 3 square, which is 81 plus 9, which is root of 90. So we got QS diagonal as root 90, which is, of course, you can write as root of 9 into 10, which is 3 root 10 taken out of the radix, isn't it? So QS is known, and you also know what is PR. So PR is known. So PR is 3 root 10. PR is 3 root 10. That's diagonal PR. QS is also 3 root 10, isn't it? So I was able to show previously that PQ is equal to SR and PS is equal to QR. Now I'm also able to show that the two diagonals are equal. So a parallelogram in which the diagonals are equal becomes a rectangle, and hence PQRS is a rectangle. I hope this was helpful to you. Okay, I hope the explanation has been helpful to you. Thank you.